Hi, welcome to video 3 of section 5, Recurrent versus Convolutional. In the last video, we saw how to write a recurrent layer in Python with Diano. In this video, we will talk about how to know when we should use one or the other. Also, when and how to use them together. So the topics of these videos are types of neural network memories, uses of convolutional layers, uses of recurrent layers, and recurrent and convolutional layers together. Using signal processing terminology, we can say that there are two types of memories in neural networks. Those implemented by finite impulse response filters and those implemented by infinite impulse response filters. We can quickly recognize one or the other as follows. If we have a moving window in the input, we are usually talking about FIRs, or finite impulse response filters. If our model has a dynamic recursive state, we have an IIR, or infinite impulse response. Convolutional layers are FIRs. Thus, their outputs have a local and specific memory about the input. We can implement convolutions in time or in space. Temporal convolutions are useful for speech and text processing, but most importantly, this type of layer is useful for spatial convolutions in images. Also, convolutional layers are usually easier and faster to train. The message here is, if your input data are images, you should use convolutions in the first layer at least. If you have speech data, you could, for example, calculate spectrograms and treat them as images. Recurrent layers are IIRs. Thus, they have a long-term memory, technically infinite memory, about the input. But that memory is blurred, with exponentially decaying information about the past. In videos, speech, and text data, recurrent layers get each time a point from the input and update its hidden states. When we are done presenting the input this way, the final hidden state can be seen as a fixed-length representation of the entire input series. This is why RNNs, or recurrent neural networks, can be naturally applied to variable-length inputs. One problem with recurrent neural networks is that they usually take longer to train than convolutional neural networks. Here's a really good example of using recurrent and convolutional layers together, which is the problem of action recognition in videos. We can think of a video as a spatial-temporal sequence. I mean, the frames evolving in time. Just like we use deep convolutional neural networks to extract features from images, here we could use one to extract features from each frame of the video, using techniques similar to what we did in section 4. This way, we transform the sequence of frames into a sequence of features, and this accounts for the spatial part of the problem. After that, we could train a recurrent neural network on that sequence of features to do an action recognition. Training this full model from scratch using both convolutions and recurrent layers could be really time-consuming. Thus, the strategy of using pre-trained models is really handy here. And our problem reduces to only training the recurrent neural network on top of the representations. In this quick video, we discussed the differences and similarities between convolutional and recurrent layers. We also mentioned an example of how to use them together. In the next video, we will train a recurrent neural network to do sentiment analysis in text.